Hello, and welcome to the Wednesday, October 17th edition of the Cluster API SIG Cluster Lifecycle subproject. Today, it looks like we have a couple of action items we're following up on at the beginning of the meeting. Chris, do you want to talk about what those are? Since I missed the last meeting, I'm not clear on what number 534 or 525 are referring to.
Yeah, 1 second.
Do you have context on those?
Yeah, I do. Can you hear me?
Yes.
Okay. Let me pull them up really quick to remind myself which one is which. But they were basically, I think they're just clerical items. The first one, 525, was just a one-line doc change. And the other one, 534, was a proposal, I think. Yeah. It was a CNI proposal. So what are we waiting? It looks like we're done on 534. Do we need any more input there, Nadir?
When it says, what does it mean when we say done? Because it looks like there's an open issue with no comments on it. So what does the done part refer to?
Yeah, also curious.
I think the action item from last week was to have the issue created to have a further discussion on the topic.
Okay, so basically it looks like the issue is that some add-ons at least need to be applied to make the cluster work, in particular CNI. And so we can't wait until the cluster is working to apply add-ons, because the cluster will never be working if we don't apply some of the add-ons.
Right.
Okay, so if we change the order of add-ons so it's applied as soon as the control plane is up, are there any things that could go wrong with that?
How are add-ons applied now?
We just basically say, like, once everything's up and running, we kubectl apply -f, whatever's in the add-ons manifest. And so we would basically just do that sooner in the process.
Right.
Which I think if you're, creating daemon sets and deployments and so forth, you might just end up with a bunch of pending pods until your nodes are up and healthy. But
yeah,
it shouldn't have any bad side effects, I don't think.
I don't think so either. Usually with CNI, everything will just sort of sit in an error or pending state until CNI comes up, and then after that, everything sort of magically starts to fall into place.
Okay. All right. That sounds reasonable. It sounds like that was discussed last week, and there maybe weren't any objections there either.
Yeah, the main thing from last week is that we didn't know if there was any particular reason why the current implementation applies the add-ons at the end, if there was actually, something that drove it other than just, the random order or just the order that was chosen.
I think that was just the order that was chosen when I put those in there, because I really needed storage classes to work. And storage classes can be applied at any point and really don't do anything until later when you actually try to use storage. I'm pulling up the add-ons that we have in GCP to see what else is in there. So what we add is we add a storage class, some service accounts and role bindings, and then we add a deployment, which would be fine to set pending, a config map, a service, which would be fine, another deployment, which is fine to set pending, and a secret. Yeah, so I don't see anything that we add as add-ons that would not work being applied sooner. So I don't know if what gets applied in the AWS provisioner as add-ons, and if any of those you think would break if we did it sooner.
We don't apply anything right now. We wanted to try to put the CNI deployment in there to simplify it and not tie it into the actuator implementation like we're doing currently. But we hit that kind of chicken and egg where we couldn't actually spin up the rest of the infrastructure before the add-ons were being applied.
Okay, that sounds good. I think we should go ahead. Oh, go ahead.
So I think one more thing that we probably discussed last week was, right now we are treating all add-ons as just in a single category that, you can just apply them anytime. I agree that, even if there's an add-on that gets applied, which lets it state in pending, it's okay. However, I think my understanding is that the belief was that we could potentially categorize the add-ons into two separate category. One is which is critical for the system's health itself to bring up, and the others which are just add-on values that that are just value add based on a particular provider, for example. And we probably the point was that we should probably treat these two different categories in a separate way so that they can be applied in a specific in the more appropriate place in the workflow, so that we don't get into a situation where we are waiting for the add-on to come on and get ready and to be active, so to speak, in order to move forward. But then there is another thing that it's waiting on. So I think that was because I think one more discussion was, do we want to, for example, care about when you apply an add-on, do we want to wait for its add-on's status to be active before we say, okay, the cluster is done or not? And again, that actually opens up an interesting question. If it's in pending, then do we just wait? Because it could be going to a circular dependency there. So, yeah.
Yeah, I think that's an interesting point, because there are certainly some add-ons, like if you think about the CNI provider or FluentD, that if they are not working, your cluster is non-functional. And there are other add-ons, like say FluentD, where if it's not working, your cluster is still working, but it's in a degraded state where you aren't getting logs. And there's sort of a distinction between those two things of your cluster is fundamentally broken, or your cluster is degraded but still works, right? Like you can still run pods, you can still run things, you just sort of are missing logs, or monitoring is another sort of similar example to that. And then there are things like the dashboard, where if that add-on isn't working, then it itself is the only thing that is broken, right? And it doesn't really affect whether everything else in the cluster is working. So we definitely sort of have tiers of add-ons, if you will, in terms of their impact on the overall user experience. Right now, I think when we talk about add-ons in the cluster API, it's similar to sort of add-ons in kubeadmin, where it's, for the most part, I think we want to put things in that add-ons file that are critical for the cluster itself to be functioning, and take sort of the other two categories of add-ons and let users kubectl apply those themselves at this point, until we have sort of more holistic approach to add-ons. So I would say, like, stick the CNI stuff for AWS into the add-ons file, and try not to put a whole bunch of other like sort of value add things in there, and then give users instructions of kubectl apply this URL if you want to add, FluentD, kubectl apply this URL if you want to add, whatever else. I think that would be a good starting point, and then we can iterate from there.
Yeah, I definitely think drawing the line between a functional versus degraded cluster is important to get into the add-ons file.
I would even go so far as to say things like the dashboard, which are non-critical components, are totally outside of the scope of cluster API. I mean, I don't think those are things that we need to touch. If somebody wants to add those aren't critical to deploying a cluster on AWS, et cetera. If it isn't critical to running the cluster itself, then we should consider that completely out of scope.
I mean, I think it's out of scope for what the project concerns itself with as far as support is concerned. We're definitely never going to support installing the dashboard, but I think if people want to opt in to using tooling from the project and bake in something like the dashboard into like an AMI or throw in a provisioning script or whatever, like it's allowable, but outside of our support scope.
Yeah, I agree with that. I'm just saying, as far as providers or cluster API is concerned, we should give the primitives there for people to be able to do that kind of stuff eventually, but it shouldn't be that every cluster has to be deployed with dashboard.
Yeah, definitely not a first-class citizen here. Okay, is there anything else on 525, 534?
I don't think so. It sounds like a number of people have some comments on the issue. Please also add those to the issue itself, so that we can get those captured there and not just here. Because I also didn't write anything particular down in the meeting notes about this.
Yeah, I was just wondering, like, having said what we just said, I wonder whether in the future we may manage to extend the notion of add-ons as such into the sort of a first-class object within cluster API. Right now, there seem to be, fairly ad hoc implementations of what add-ons mean on provider by provider basis. But it seems like maybe there is room for having a first-class object spec for add-ons, and the object would like describe whether add-on is sourced from like a Helm chart or some manifest at a given URL, and whether it has any customizations or parameters or whatnot, and have a way to drag that object and upgrade it over time having a way to drag the kind of the collection of objects which represent an add-on over time and update them in the future, etc. Seems like potentially plausible idea to me. I don't know what folks think here. I'm not suggesting that we mandate any specific set of add-ons within Cluster API, but just generally have a shared definition of what an add-on means and how it could be defined and like installed and updated.
Yeah, I think that makes a lot of sense. I think if you look at the way we're sort of shoehorning things in right now, it's not particularly great, because on creating a cluster, we apply a couple of manifests. But then if you go later and you update the version of your control plane of that cluster, that has no effect on, like, now we need a different version of an ingress controller because our control plane got updated. Or if we go and update the versions of nodes, there's no notion of like, now we need a different version of the CNI because we're updating our nodes, right? It's sort of up to an operator to orchestrate those things correctly together, right? Which is not a great situation.
Yeah, so I've started drafting a proposal within EKS Cuddle project, because that's currently my place where I experiment with things. But it seems like, if people are interested in the future, I'd love to share whatever comes out of the experiments that I'm doing in EKS Cuddle.
I think that'd be great. I think also that I think we shared it before, the Google project, which is sort of just defining a bundle which is supposed to address the specification of these things. So we could at least have a shared specification of this version of Kubernetes needs this version of, or works well with this version of the Weaveworks CNI provider, for example.
Yeah, right. Yeah,
we probably want to come back around to that at some point, because if you look at the way right now we're specifying all the different pieces that go together to make a cluster, it's spread across a whole bunch of YAML files. It's really ugly. Like, I was watching Chris's video from last Friday from TGIK about the cluster API, and at one point she's like, "Oh, I forgot to add this flag with this other file that we also need," and it's just like it's particularly convoluted the way you have to specify all the different pieces right now. So it'd be great if we could sort of put those things together in a better packaging format.
I think it's a little more. There's another aspect of the convolution too, in that right now the cluster cuddle workflow kind of conflates some of the topics of what does it take to kind of bootstrap cluster API itself, what does it take to actually create a cluster using cluster API, and then what does it take to pivot that cluster to a more stable cluster too. And as we've tried to start describing cluster API and how to use it and the workflows, that's caused a lot of confusion for people that we've been trying to on-ramp.
I guess also the other piece is that we sort of haven't even covered in cluster CTL yet is upgrades, right? So it would be nice. I see some people smiling, and it would be nice if the bundle certainly allows us to describe a new set of target versions, and I'm doing some work on how you apply a bundle, but it would be great to maybe put that into cluster CTL or into some other mechanism that cluster CTL then utilizes, because it is a hard problem.
Yeah, I think that comes back a little bit to what Jason was just saying, because one question is clusterctl just a bootstrapping tool that's sort of fire and forget, and if after that we just use kubectl, directly, or do we need like a clusterctl upgrade command that wraps the kubectl commands you could run yourself and makes them more user friendly, right? Because I think once you have the cluster up and running, you can just use kubectl to manage all the bits that have been provisioned, right? That's the idea, is you can kubectl edit the version of your machine deployment and get new versions of nodes. You can kubectl edit the things that run your control plane, right? I guess those are deployed as static pods today, so maybe that doesn't quite work. But the idea was that you should be able to kubectl edit the definition of your control plane and have that updated as well. And so that after that initial bootstrapping phase is finished, that everything after that is declarative through the API. And I don't think we aren't quite to the state where that actually works. And even if it does work, it's not clear that that's necessarily good user experience, even if it's possible. Right?
Yeah, I wasn't trying to.
Oh, I was going to say, I have real strong opinions about the workflow, just based on lessons from Kubicorn, lessons from COPS, and the way upgrades were managed there, and the fact that upgrades are virtually non-existent anywhere outside of COPS. I would like to take a stab at writing a proposal for a workflow based off of what kind of Robbie was just describing, of what it could look like to have a kubectl very declarative approach, and potentially like where the responsibilities of operators and controllers would be along the way, if that would be agreeable to folks.
I would love to see that. I mean, I think everyone would love to see it. I don't know if you can give us a sneak peek of how you're thinking about doing it, but like, yeah, to me, it's a very difficult problem, like in that we either involve clusterctl or I don't know.
Well, so users want like the tool, right? Like they want to be able to sit at the command line and have all the visibility and have the tool that just makes upgrades work seamlessly. And they want it to kind of work well. And then if something goes wrong along the way, they want it to either undo itself or have some sort of reasonable state that can recover from. And they just want visibility as things are happening. I think with the operator pattern we've put in place, starting with a kubectl edit and just changing the version number from n to n+1, and then having some sort of system in place, whether that's just watching the logs or we actually have like another tool that will actually go and query a server for metrics or something that gives you an idea of what's going on as we're sort of going through this upgrade, I think would be important. But I think there might be a use case for another layer of software to orchestrate this whole upgradey bit, because there's a lot that goes into it, as we learned at COPS.
Another layer that wouldn't be clusterctl, but that would be...
It would be some sort of orchestration controller that would manage mutating CRDs and waiting until the CRD reaches a certain state and then updating a record possibly somewhere and then moving on to the next one. Real similar to how stateful sets work, but I think a little more involved. And at that note, that opens up this whole Pandora's box of what is our upgrade strategy? Do we do a mutable upgrade? Do we try to upgrade in place? Do we have different controllers for different strategies? And then it sort of recursively digs in from there.
I think it'd be great to start to talk.
Oh, this is Cindy from Samsung. I just wanted to say we made a stab at upgrade, and I would like to see how the group wants to do it, but we did in place upgrade, and we do have an external tool that manages the upgrade, like you suggested. It's our RESTful interface. There's a thing that waits for the control plane to be done and then does each worker one at a time using the kubectl API commands. So yeah, I would like to see what the group comes up with as the standard, but we have made a working example.
So Cindy, when you say in-place upgrade, are you talking about in place for both control plane instances and the nodes as well, or?
Yes, yeah, both the control plane and the nodes, so they don't change IP addresses, but they reinstall everything. And they keep trying, the controller just keeps trying to match the desired version, and we'll keep trying, even if there's an error, it will every time come around. There were a few, yeah, there were a lot of little gotchas on upgrading your package to a specific version. Sometimes a newer version will come down. It's mapped to kubelet and kubeadm have some mappings when you use upgrade, at least on Ubuntu. And So there was some work done too to make sure we get the right kubelet version matched to what the user specifies. So there was work done there too. But if you want to look at it, it's in the SSH cluster API provider SSH example that's out there done by Samsung.
Hey, I have a question for you guys who have worked on upgrade. Have you guys, how did you guys handle incompatibility between packages and versions of Kubernetes? This actually came up recently. Some customers are, they don't upgrade very often, so they may stick with like one version of CSI, and then a new version of Kubernetes comes out, and it mandates that you upgrade to a new version of CSI, but they don't know that. So how have you guys handled that in the past, in this upgrade process?
I don't know if you're talking to me. Yeah, there's use cases we probably haven't explored yet, but we're assuming we have an API that is used by a UI, and so everything's done through that. But if someone went behind your back and did an upgrade, you would know what version it is. We used the get nodes command to know what kubelet version is currently running. We always match the desired version with that version.
So do you keep a mapping between versions of let's say the kubelet or the control plane and like different plugins versions?
We don't keep any mapping outside of what's stored in etcd. So the spec has the desired version in etcd, and then we always check in the upgrade processing in the controller, what is the actual kubelet version that's running right now. And so we do the get nodes command, the kube control get nodes command tells you the version that's currently running.
Okay.
So if we find out that they do not match, the desired and the current do not match, we attempt the in-place upgrade where we just reinstall the control plane first and then the kubelet.
Okay, so
you're asking about how do you map the version of the control plane and the kubelet components to other packages on the system and keep that compatibility matrix sorted.
Because a lot of enterprise customers, they don't want, they tend to hold back on upgrading. They'll hold on to a version for several releases, but they may want to upgrade this is actually a real case. It actually came up recently. I can't remember the specifics of it, but it had to do with CSI. They didn't want to upgrade CSI because that may require some significant changes to their infrastructure that they haven't tested yet. And the latest version of Kubernetes required, required a CSI version upgrade. So I think to serve the enterprise customers, I think we need some way to warn users that you don't want to upgrade this component because it's incompatible with this other component.
Yeah, I think there's two things I'll throw out there, Locke. One is that there was a recent proposal, I think coming out of SIG release, for creating an LTS version of Kubernetes. I don't know if you saw that. Which I think is largely sort of focused on more of this enterprise that don't want to upgrade nearly as often. And the other thing is that there was an email thread, I think yesterday or maybe this morning, where somebody asked about sort of the different supported versions and how you can tell which different versions of components go with which version of Kubernetes, which is along the same lines of what you're asking. And Tim basically replied and said, that's what the test matrix is for. Like, we test a certain set of components all together, and that's sort of what we know works. And different, Brendan replied as well and said that, different managed offerings of Kubernetes, like, this is part of the reason they restrict like which CRIs or which CSIs you can run with which version of Kubernetes, is because that's to reduce the test matrix, and it makes it supportable if you say, when you run this version of Kubernetes, you can only run this version of the storage plugin. And so I think there is space in the ecosystem for vendors to say, we'll support different pieces of this test matrix. Right? We'll test these different pieces to help our particular customers if they need that. But I think as a community, we will probably continue to try and restrict which things are tested, that we test sort of as a whole, and that we qualify, just to keep ourselves sane, right? Because otherwise the test matrix explodes to the point where we can't keep it working.
Okay, so basically it's up to the vendor.
I think once you start diverging from the set of things that sort of we as a community say, for version 111 of Kubernetes, we're going to run this container runtime and this and this and this. And if you look at the kubeadmin tests, they have a particular set of container runtimes and storage plugins and so forth that they test. And we can certainly look at augmenting those. But every time we add a new piece to that matrix, it increases our burden of keeping everything running, right? So we're incentivized to keep that relatively small. And again, if you want to go outside of that, then vendors are perfectly happy or perfectly able to expand the test matrix themselves, or have a slightly different set of coverage that they want to test and do for their customers.
And I think actually, I missed the thread that happened, but I think there is actually a recommended set of versions for everything, and the plus or minus one type versions are more needed for upgrades. So it would be bad if during a rolling upgrade, when your kubelet moved versions, that everything magically broke because you were actually running an incompatible set of versions. So I think there is actually for each Kubernetes version, there is a real recommended version that you probably should be running. And as Robbie said, if you deviate from that at your own, recommended, I guess.
I'm going to jump in and table our upgrade conversation because I feel like we've gotten pretty far off in the weeds. It's a good topic to move forward if that works for folks. And we're already 30 minutes into the call and we're still on our first item here. Okay. Next item, remove the hold on 525. I was able to do that. I think that's done and merged. Marco, if you need anything else, let me know. Next, it looks like Marco also has a proposal for upstreaming provisioning scripts, or bootstrap scripts, as we've called them in the past in Kubicorn. And it looks like that's a pretty well thought out doc that Marco has proposed for us to take a look at. Do we want to go through this, or Marco, do you want to give us a high level of what this is and where we are with it?
Okay, so I have left this document and finished it today. For now, I think I will just leave it for now, and you can go through it and we can discuss it on some next meeting. I have talked a little bit about that on some past implementers office hours, but now we have the proposal ready, and we would love to hear some feedback or see some comments here. So far, looking from some high level and motivation behind this proposal is that we don't have any bootstrap script or any mechanism to handle provisioning process and bootstrap script. So everybody has to write them themselves and to handle how that everything will be executed and all that. But if we compare the provisioning, or how we call bootstrap script, we can see that most of them are same or very similar. So providing some scripts in the cluster API could help a lot to get started, especially that in this case, we could support many setups and many operating systems. And what we are doing right now is something that we put the bootstrap script in examples directory in cluster cuddle, or we have something like that is usually, and that can be hard to maintain, hard to find, and hard for end users to work with. So maybe something like to have such in cluster API to be able to be used by implementers could be nice for both implementers and end users.
Okay, so we would potentially host sort of blessed bootstrap scripts as a community, and we would host them in one of our cluster API repositories. I mean, I think this touches a little bit on what we were talking about on the compatibility matrices and package dependency. Like, it would give us a way to at least say, we're going to install these versions of these packages, and these are configurable bits and these are not configurable bits. I think the one thing about bootstrap scripts in general that kind of makes me weary is if we are encouraging folks to run these at runtime, the state of the internet is subject to change at any given operation. So we're back to the whole AMI discussion again of whether or not we want to try to provision a node at runtime, or if we want to bake a lot of this stuff into an image. I think in either situation, having a solid example, or at least a solid working script for getting to that state, I think might be helpful. Whether or not we advertise them as something we support or not, I think is a different story.
Marco, I haven't had a chance to look through your doc yet, but when you compare like the bootstrap scripts across providers, you say that they're largely the same. Are you anticipating the parts that are not the same to have a way for the providers to inject a little bit of their own sort of custom script in at the end? And we have like the sort of shared blob and then the customized blob. And is that going to be sort of as maintainable as everybody just having their own copy of the script?
Yes, something like that. So in the proposal, I have mentioned that this may be realized using Go templates. So some stuff can be templated out, and the user and the implementer can inject into the script what to be populated and what to be used. But also, it is out to be decided when we want to stop. For example, do we want to say just install Kubernetes, configure kubelet, and all that, but also set up Kubernetes or no? For example, what we are usually doing right now is execute kubeadm init or kubeadm join. Do we want to do that from the controller or to do that from the script? That is also one thing to decide. Also, the thing I mentioned is CNI should be handled. This is also a problem, how that, and this is the customization after the cluster is set up. So this is still not defined by the proposal, but we are looking for any comments and any feedback, any idea how that can be handled.
I would say what COPS did is we did as little as possible in Bash, and we put a lot into Go, and I feel pretty happy about that decision, despite having then this like Go thing that everyone has to download. It means that like you can like find out what OS you're actually running and like perform the correct operations based on that, like whether you're a yum or an apt or a uninstallable OS, right? It is easier. So I think the idea of putting it into, I like the idea of putting it into some form of shared functionality library. I do think we'll end up with finding that it is easier to write a Go helper which rapidly balloons in size as we move on.
Yeah, I guess I would err towards the first thing you said, Justin, which is to try to do as little as possible in the initialization script. And I agree that having a lot of Bash is not a great long-term solution. So if we do need to do more than as little as possible, using something other than Bash sounds like a much better plan. I don't know how much of NodeUp you think would be potentially reusable, or how much we want to just say, like, let's try not to let it balloon and let's try to do less.
I think it'd be nice to try starting from scratch. We can certainly look at what's in NodeUp. I do worry that we're going to quickly decide that we want most of the things that are in NodeUp, but that's okay. We can certainly, like, there's more in NodeUp than we need, and I think we want I think we probably want the task-based thing, and I think we probably want task-based retries, and I think we probably want the task-based retries. So that's the main thing. But I don't think we necessarily need like as much of the comparison logic as like is in there currently. But task-based retries, I think, are the big one.
I think one of the huge wins we would get from having a Go style library like NodeUp. In my mind, if we had NodeUp, but also was able to report status along the way to the rest of the system, I think we would be in really, really good shape. And if that comes in the form of forking NodeUp or starting from scratch or whatever, I do think we have a really good opportunity to provide a lot of visibility into our initialization stuff, and we should probably take advantage of our statuses and our other objects as we're initializing nodes.
I guess that could tie into your upgrade thing as well, right, Chris?
Yeah, I mean, creating a node and upgrading a node are pretty much like two sides of the same coin.
I mean, Ilya put something in chat about if you go the immutable approach, upgrading is just creating at a different version. Whereas if you go with the in-place approach, then you actually need something that can mutate state on a node, right? So those are very different.
Yeah. But a lot of the parts of the system you would be touching are the same, just probably in different order and with different configuration.
We actually had something interesting in COPS as well, where the kubelet bootstrapping token, someone submitted a PR or actually a whole component which does the kubelet bootstrapping token in a differently secure way from how it's done in OSS, which is sort of like another component that runs there. It'd be interesting to integrate that functionality in there as well. To me, that belongs in the bootstrapping. And something that occurred to me as well on that front is if that bootstrap component actually communicated with the machine controller, there is this opportunity for like a nice channel that like we have a component that runs on the master, and we have a component that runs on the node now, so we can do all sorts of like nice advanced initialization without having to like marshal it through bash or do a lot of that sort of stuff, or marshal it through S3, which is what COPS does.
Yeah, I was just thinking about this. Well, I mean, I've been thinking about this a fair bit, right? I kind of tend to personally favor anything that is basically the least amount of logic that is outside of like kubelet or the process manager, whatever that system D or whatnot, and whatever the native bootstrap thing there is, like cloud init, having the least amount of logic outside of that, and having all the configuration that needs to be generated on sort of node by node basis or whatnot, kind of existing, pre-generated before the node bootstraps and passed as user data, instead of having that complex logic inside of that user data that does crazy things. So that's what I tend to favor, essentially. And I've been able to do that with Amazon Linux and EKS recently, and in the past with Linux Kit, we've done a fair bit of that stuff. The only gotcha there is like, how do you get the CA certificate for kubelet to use, right? Because if you pass that in, you kind of have to have a way of refreshing that. But other than that, I haven't quite found ways to break this model, other ways to break this model, right? So CA certificate could be potentially upgraded and by other means through a potential control or some sort. But the other thing I did think about is that perhaps in some cases, even if we do this sort of thing, it may be still possible to let user upgrade things in place whichever way they want, and they could use their existing tools like Ansible or whatnot for that. Without, as long as we don't get in their way, right? So we set up some nodes for them and perhaps provide a way to manage nodes declaratively in an immutable fashion, because that seems easy in the cloud at least, and doesn't require us to write files to disk and things like that, because that's a pretty messy business as far as I'm concerned. But or calling out to any like OS package managers or anything like that, but let user sort of provide just as an idea, right? We could provide an immutable way of managing nodes and their upgrades, while user may still wish to implement some way to mutate state of each individual node in their own ways. They could be a thing. So like we would treat nodes immutably, but wouldn't necessarily like mount all the file systems read-only or anything like that. It would be up to the user what happens there and what OS they choose to use.
I guess my concern is that I feel like we're often going to need, and there may be workarounds to this, that we're often going to need like the ability to install things. And the sort of the examples I would give would be CI and just the sheer volume of images we're going to be maintaining if we think about like the versions of Kubernetes that are still supported, including all like the dot releases, which people might still run, right? Like there's no requirement, I don't know what we're on now, but like suppose we're on 110.5 now, or 110.5 is the latest, like people might still legitimately be running 110.3. And if there's another Intel like workaround needed in the OS, we have to like go and patch 200 AMIs. Which is so we'd need some workflow to make that workable, I guess.
Yeah, that's also true. That's I guess that's something I forget now that that I have ESCadal HUD. Most of the time, when there is an upstream vendor of the AMI that I use to whatever extent that I happen to use it for in ESCadal at the moment. So yeah, but if we are the vendor of the AMI or whatnot. I haven't quite considered that point here, of course.
Did they have?
Okay, with regards to the upgrading and patching, wouldn't it make sense to write the script or Go app or whatever in a way that it's like declarative, like if stuff is already there because it's a pre-installed AMI, just don't do anything. If it's not there, install it. Then we would maybe just maintain a limited set of AMIs and not for every possible combination.
I mean, that to me makes sense. That's what COPS and NodeUp does, and that's sort of some of the other logic that I was hoping we wouldn't need, sort of the find comparison logic. But we can probably form a simplified version of that. It's what I think it's like what Ansible and stuff do as well, right? Like it's not like
we have at least some of that in Bash and QUp as well at this point, which is pretty ugly. And most of the reason we have it is for CI, right? Like Justin was saying earlier, I think when you start looking at CI and wanting to be able to dynamically replace a whole bunch of things to expand your test matrix, it becomes a lot more complicated than we want to have this one sort of golden configuration that we know that works, that is stable and static.
But we could do something messy for CI, right? It is reasonable to have a ugly bash script that like blasts files onto the disk and that we tolerate for CI, but don't like encourage for production. So it's not a like no. It's just that in my experience, it's the other thing is it means that like the COPS approach means that where we will install anything that's missing means that users can run it in theory any AMI, or like they can run an official upstream Red Hat or Ubuntu release. And those often get released more often, including like the very latest security fixes. Like they tend to go faster.
They tend to go faster than
the COPS AMIs than me, yes.
Yeah, I mean, I don't think there's realistically any way that you would be able to go faster than them. You might be able to try and keep up, but it would certainly be a fast-moving treadmill, right?
I guess at this point, I'm kind of wondering whether it would be reasonable to discuss in terms of like provider variants and stuff. Maybe there's a good reason for a Node OS provider sub API to exist. Just putting it out there. I don't know whether that's been discussed before.
There are definitely differences between the different OSs that are substantial. So I agree with that idea. Like the most notable ones are like how you install software, if you can install software at all, and the paths to which you can write and to which you can execute. So at least with COPS, we have some logic that like has to point things into different places. I do wonder whether it would be possible to find something that works everywhere, or at least in all the OSs that are in use. But it is also tricky on AWS because it's not trivial to know from an AMI what the OS is. But you could probably ask the user to tell you, I guess.
Yeah, that's I think what I'm thinking about. Yeah, that the user kind of would probably know when they use a specific AMI, right? Or even like with the with any other providers like SSH provider or anything. Right? And the idea is that there you could sort of have slightly different variations of how a specific OS is managed, how a specific implementation is done. Right? Because right now it seems like for each cloud provider there would have to be, for each cluster API provider there would have to be some kind of node bootstrap implementation, right? And that node bootstrap implementation is potentially looking at handling all sorts of different OSs.
I think it's really important for us, we're talking about AMIs and, that's great for GCP and to be fair, even OpenStack, AWS. But once we start talking about SSH, once we start talking about doing bare metal, I mean, having pre-baked images isn't a thing. It's not something that we can work with. It's not something that we can play and throw around in. And we're then very significantly limiting cluster API to implementations just for specific cloud providers that have the ability to offer that, or where you have the ability to select a set of images or upload custom images. I know in Germany, you've got Hetzner. You run with what they've got. They give you their pre-baked images. You run those, or you don't run on Hetzner. So it's kind of, it's great in theory to think and talk about these pre-baked images, but I don't think that's something that we can consider as a long-term goal if we want to make cluster API available outside of just the major cloud providers and things like VMware, OpenStack, etc.
Sure, but you could also, imagine a use case where instead of running kubelet directly, like you'd start a container or run a VM by KVM or something of that sort, and that would be your actual node process would be like a VM inside of that bare metal machine, and that could be a potential flavor that some folks may prefer. So it seems like there may be a room for that, and different sort of node bootstrap providers essentially, because now it seems like we're kind of looking at the problem from a very wide angle, and maybe we could narrow it down by thinking about something like this. I don't know, just an idea.
I think the other thing to keep in mind is that part of the reason we have the different providers and different provider implementations is to allow flexibility. So it's possible that in environments that are similar enough, like you could imagine GCP, AWS, Azure, maybe even OpenStack, VMware, if those are all similar enough that we want to reuse something like pre-baked images, we can do that. That doesn't preclude us from having a different solution for SSH or bare metal. It may just have to have more different code, right? But I don't think we should preclude ourselves from sharing code across providers where it makes sense. So, and that's not necessarily in favor or against pre-baked images in particular, but I think there are probably lots of things that are common across the cloud providers that are very different from an SSH provider or a bare metal provider, right?
Oh yeah, that's certainly understood, yeah.
And I would say I do think pre-baked images are great if we can do them, right? They are much faster to boot. They have much fewer external dependencies.
They're harder to debug though.
Yeah, I guess I'm trying to suggest.
Justin.
Yeah, I'm trying to suggest that it may be a kind of thing that should be up to the user to decide whether they'd be looking to use pre-baked images or something else or whatnot, right? Or they may be looking to use like a SSH provider on AWS or I don't know what else. Yeah, I just thinking whether. Yeah, I don't know. I'm not. It's not like something we have to discuss right now. I decide right now, but just like basically, yeah, whether we should keep discussing this as a sort of a general problem of cluster API, or maybe we could in each individual provider, or maybe we could define image bootstrap, node bootstrap provider of some sort, or also as a kind of a separate notion.
We're running a little low on time, but I did want to ask Chris one question based on what you just said, which is you think that the pre-baked ones are harder to debug. And can you give like a quick explanation of why you think that's true?
I just think that as someone trying to debug a system with a pre-baked image that you do not have visibility to, there's an entire exercise of figuring out how the image was generated and what could possibly be going wrong with the image generation process that could be affecting your downstream problem. If you're kind of doing everything at runtime, like it's riskier, but at least all your logs and all your debugging is in the same place. A great example is in COPS. If we're generating an image, and when we had the kernel bug like 2 years ago or whatever, we had to go and dig through Git repos to even figure out how the system was being built before we could even start to debug a problem that was several steps downstream.
The flip side is it can be actually easier if you're building the image yourself. You can in debugging utilities and
yeah, but in most situations, I found engineers are not the ones building the images.
We also just had a bug, I think, where like we did a one-time initialization, and if you grabbed an image from a running image, then the one-time initialization had already been done, and so if you tried to reuse it, like everything tried to come up as like the same node or the same cluster or something like that, right?
Yeah.
It's that sort of, I mean, that's just a bug, but it's sort of, it is a more, you have to be careful in the workflow.
So I have one additional question to Marco. So Marco, in your proposal, I mean, I understand the benefit of having maybe a common startup scripts and, you know, definitely abstracting out. But does that also mean, for example, in cases where when a provider is trying to install Kubernetes, right now we're assuming that this is all just pure vanilla upstream Kubernetes that gets installed and set up. For cases like, how about if a provider has its own, let's say, slightly customized distribution of Kubernetes, and then they want to put that in this setup, I mean, what would be the ways? I mean, one thing I guess is we can probably override the images, but I'm just curious if you guys have thought about, you know, and that kind of goes very similar to the CI part that was brought up earlier, that, you know, specifically for the CI case, we probably want to actually do that, and which is okay to go more, you know, half-assedly to deal with the CI case, but I think there is a general requirement that we might want to handle as well. So any thoughts around that?
So, not at all, but well, I'm not sure. We have not thought about a lot about that. Maybe having some options to customize that parts, or even to limit that we support only basic part of Bootstrap scripts, and then to say that user need to provide their own or something like that. But this is still a part that we have not thought about a lot. I think this is a good comment, and we will be looking into that. So, but for now, I'm not sure.
So to follow up on your original proposal here, Marco, I think there's a lot of good points brought up in this, and I think we probably at some point would really benefit as a community of having an idea of what an initialization or provision or bootstrap script looks like and what those steps are along the way. I think what this last discussion kind of showed us was we aren't sure how we want to solve a lot of these problems yet, and we have a lot of good ideas. We just need to start wrangling them all together and figuring out what the tooling is going to look like.
Maybe it makes sense to put this proposal in Markdown and pull requests into the cluster API repo, and then people can continue discussing there.
Yeah, that sounds like a very good idea. Yeah, because like, well, right now we seem to be saying something about an initialization script, what that may look like. But I'm thinking, well, is it a script, or is it a whole other API that would be called a node initialization provider, right?
Yeah, can I request we like wait 1 week to turn it into Markdown so people can comment in the doc first? Because I find that normally when you're trying to make comments, it's much easier to do in Google Docs on sort of the first pass until things settle down a little bit.
Yeah.
And then we should turn it to Markdown so it has a sort of a permanent home where people can get to it more easily. But since it sounds like most people on the call hadn't seen the doc before the meeting, let's not turn it into a PR quite yet, because I'm guessing that the first pass people do will have a lot more comments than the second or third pass.
Yeah, I think it's okay to leave this in Google Doc like for a week before the next meeting, and then do the convert to Markdown and create a PR.
Perfect. All right, with the last minute, Siddharth, you had a question. Hopefully it's quick about the machine activity interface.
Yes, actually, it's a very quick question. So, so recently with the vSphere implementation for where we moved to Go Mommy, we were trying to basically when we were trying to implement the create, at least I kind of modeled that as a state machine in itself. But then that kind of brought up an interesting question that I wasn't sure the answer was, which hence I want to bring up here. Like, what is the expectation in the actuator interface of create? Is that like a sync call that, when the controller calls the create, the expectation is that when it comes back, that the machine should be provisioned with the IP up and running? Is that what the expectation is? Or, I just want to know what was the behind the scene intention before when we created that?
You guys understand what he means by that?
Yes, and I don't recall. I don't know if I'm hoping somebody else on the call does.
Can we re-ask that? Sorry, I'm a bit confused still.
Sure. So essentially, the actuator interface method say create. My question is the expectation then when the controller actually calls the provider's create method, that when the controller comes back to the controller after the create method is called, is the expectation that at that point in time, the underlying infrastructure will have provisioned the VM, booted it up, and have gotten the IP ready, and only after that the underlying controller will move on from that create? I mean, is that like more like a sync call, right? That it waits.
Yeah.
Yeah.
Okay, so I think to reword the question here, it was when the higher level controller calls the create for a specific provider, what is the assumption in the software that the create method should return at? Is it an asynchronous or a synchronous call? And what are the boundaries of a create being complete? I don't know if we explicitly defined it as a group, but I definitely have found that it's easier and much more advantageous to have the create method hang until the instance comes to whatever a ready state would be, an IP address being a huge part of that, personally. But I don't know if we actually called that out as a group, though.
Should we call it out? Because a lot of the contract for the actuators are not actually clearly defined. We've actually had to look at the cluster CTL code and the controller code to see exactly what it's doing. Like for instance, at the end of create, there is an expectation that there are no annotation. If we weren't looking at the cluster CTL code, we wouldn't have known that.
Yeah, I think there's definitely a case here to provide some verbosity to the interface and what the expectations are. And at any point, if we can guarantee these expectations with software, I think that's also important.
I suspect this is going to be like the early days when, like, I did a lot of work filling out the cloud provider implementation for AWS. And at the time, the cloud provider interface I mean, it still is a little woolly, but like certainly we had to make some like assumptions clear. Some things had to be changed because like load balancers are different, IP based on GC and name based on AWS, and those things fed through. So I think it's very much, we have an implementation, but we almost definitely need to make that, we're going to have to change that interface and make it better documented, because we don't even know what the assumptions are, I don't think. Like people have probably assumed that it's synchronous because it's fast on GCE, and they've assumed that it comes back with an IP because it's pretty fast on GCE to do that.
So our assumption is not just that it's async, but that you can continue to call that over and over. That's our current implementation, and it's based on our knowledge of how the controller works. This is the old code, not the...
Document one. I think I renamed one to like create load balancer, from create load balancer to ensure load balancer was one, to like make clear that it had to be an idempotent method. So I imagine that this is going to be the same sort of thing. You're going to have to, when you see these things, it'd be great to like write documentation on the interface and rename it to make it.
So just to kind of shortcut some of this, there's already issue 505, which is open, and there is a Google Doc that is already in place to discuss as a community what the expectations we have are for the interfaces and what our dependencies are for that. So I've pasted a link to the issue and the doc into the chat. That's also issue 505 on cluster API. And if we can take discussions there, that'll be fantastic, because I'm already working on it, and I hope other people will please, dear God, contribute, because once we have some kind of common expectation there, we should add that into the code and put those specifically. I think that was the intention, was to put those specifically into the code of something like the skeleton, or even just on the types of the interface. So
Okay. And on that note, we are over on time. And if folks want to continue the discussion there, I think that's a good stopping point. And Jason, we can pick on you next week if that's okay.
actually, Cindy, if you know David E from the Samsung CNCT thing,
Right,
can
I
you
do.
send him my way, please?
Okay, and tell me your name once again.
I'm Jason. You can find me on pretty much everything as Chaos Alpha. This is a horrible choice of name.
Okay.
It's in the chat.
Okay, thank you.
Awesome, thanks.
All right. Thank you for joining, everyone.
Thanks, Chris, for keeping us on time, or mostly on time.
Yeah.
See you guys soon.
Bye,
Thanks.